All right, there we go. Can everyone see the board? Is it too bright in here? Do we need to shut some of those windows? Is it too glary? Everyone's okay? All right. So let's take a look here. We have today, we're going to review for the exam. And then on Thursday, we'll have our first exam. It'll cover 2 sections out of the book, 2.2 and 5.1. For your exam, you may have a calculator, but you cannot use your phone. So make sure you bring a handheld calculator with you. And then you're allowed to have a cheat sheet, which I talked about last time. 1 standard sheet of paper, front and back. Steps and formulas only. You cannot have any worked out problems. Okay? That's what you're allowed. Any questions on that? All right, so the way that I'm going to work through today, and I actually might move because I need an extra table, so let me move over here. What I'm going to do is I'm going to go through review problems. And I have some problems, I've already picked them, and I'll tell you what pages they're on, I'll work the problem, and then I'll give you a problem that you should work yourself at home, all right? I'm going to do, well, let me just tell you what page I'm going to start this with, 2.2. If you can do the stuff I do today, you'll be fine for the test. I'm going to start this all out on page 179. What I'm going to do first is number 31. And then in black here, I'm going to put a little arrow. What you should do at home is number 32. That's the way this whole day is going to go. I'm going to do a problem, and I'm going to tell you what you should do at home. Now, in my other class, remember I teach this class at 9:30? In my other class, I did number 32 and told them to do 31. In other words, if you were to go onto my YouTube channel and you were to watch the video from today of this class, I would do all the odds. If you go and find my other class's video, I do all the evens. So that way there's videos for both. Does that make sense? Okay, so that way you have the full coverage if you want it. I told you in the beginning of the semester that I've done this before where I project everything up here, and I was surprised that my students didn't do that well on the first test. I told you last semester they didn't do so hot. And the review that I did, just like this video, I went back and I looked at it, and guess how many people watched the review? Yes, 1. I had 1 student out of 2 classes. That surprised me because it seemed like, if I'm going to have a test and my teacher tells me these are the problems that I'm going to put on the test, and here's me working through problems like it, that a student would take the time to go back and say, all right, I should probably look at that. I mean, that doesn't say they didn't study, but they didn't use the video. So I don't know. We'll see what happens. Maybe you will, maybe you won't. But I can actually keep track of that sort of stuff, like how many people watch it. Okay, here we go. 31 is what I'm going to do now. So 26 equals 7x minus parentheses 2x plus 9. Now I will go through these a little faster than I normally would because I'm going to try and get through this whole review before class time's up. And this is a review, so I'm assuming you've done your homework, you're familiar with these things. So if you have any questions on a step, either stop me or make a note and come talk to me, all right? So here we go. First thing, we have a linear equation, and the first step for linear equations is to remove grouping symbols. So I'm going to remove these parentheses by distributing that negative sign, which we talked about as being a -1, through the parentheses. -1 is going to go through. Everything else gets rewritten. 26 equals 7x, what? Minus 2x minus 9, okay? Now I look for fractions and decimals. I don't have them, so then I collect like terms. So I look on the left, 26, I can't do anything with it. On the right, I can put some stuff together, can't I? So 5x, that's 7x minus 2x, minus 9. Now that I have collected all things together, I want to get my variable term on one side by itself, so I want that 5x isolated. It actually is isolated on the right. I just need to get rid of a negative 9, so I'll add 9 to both sides. Add 9, and we get 35 equals 5x. And now to remove the coefficient in front of x, or remove that number, we divide both sides by 5. So I take my 35, divide it by 5, take my 5x, divide it by 5, cancel. 7 is our solution. And I'm not going to check it. I'm going to move on. Questions? All right, next one. I'm going to do number 35. You should go home and try and do number 36. All right, so here I go. I'm going to start out with negative 2, x minus 4, minus parentheses 3x minus 1 equals negative 2 plus parentheses 2x minus 1. Grouping symbols first, right? So I'll be distributing a negative 2 through this first one. I'll be distributing a negative 1 through the second set. And on the right side, what do I distribute through? That plus is really like a positive 1. So that will go through. I'll put a little 1 out there. And that was a negative 1 on that second distribution. So we'll have negative 2x minus 8. Okay. Plus 8 minus 3x plus 1 equals negative 2 plus 2x minus 1. So that's distribution. No fractions, no decimals. Collecting like terms. The left side, I should collect negative 5x plus 9. Right side, negative 3 plus 2x. Or 2x minus 3, you can write it either way. Am I going too fast? Need to slow down? No. Now what? So collect all your x's on one side, and you get to choose. So I'm going to get, I've been told here, I should do this, minus 2x on both sides. You could have added 5x, right? Neither way is wrong. You get to choose. The 2x's on the right will cancel. On the left side, I have how many x's? Negative 7x, right? Plus 9 equals negative 3. That's kind of weird. Now what? Minus 9 both sides. So we're trying to isolate the variable term. So I'm going to subtract 9 on both sides. They go away on the left. I get negative 7x. And then on the right side, negative 12. Next thing is to divide both sides by negative 7, right? So I'm doing negative 7 on the left, negative 7 on the right. Negative divided by negative, positive. And you can just leave it as 12 over 7 because that can't be reduced. Whoa. Is that all right? All right, sign-in sheet is coming around, if you don't mind. Okay, the next problem that I'm going to do is number 37. Whoa. I'm going to do number 37. And you should go home and try and do number 39. So 37 is as follows. We have x plus 2/3 x, oh no, sorry, 2/3 equals 3x minus 5/4. So we have no grouping symbols here, but we do have fractions, right? If we had grouping symbols and fractions, which would we do first? Grouping symbols always, right? So I'm going to just get rid of fractions. To get rid of fractions, I need an LCD, don't I? So I look at all my denominators. I only have 2 of them, 3 and 4, and I make a list. It's going to be 12. It'll be all the multiples of 3, 3, 6, 9, 12, 15, 18, and then all the multiples of 12, 4, 8, 12, 16, 20, da, 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 da. And then I go and find the least number in both lists, which is 12. And what do we do with that 12? Multiply it, right? Both sides of the equation. So I like to throw some big old parentheses out there. And then I like to put my left side inside that parenthesis and my right side inside that parenthesis with my 12 sitting out there ready to go. And I'm going to distribute through. So my distribution, I should have 2 multiplications on the left, 2 on the right. What do I get on the left side? 12x minus or plus? Plus 8? Okay, good. Equals 36x minus 15? Okay. Minus 15. Now again, because this is a review, I'm not going to go through like how that happened, but what we did was put 12 over 1, right? And then we multiplied across. We did that a few times in class, so you know, if you have trouble with that, again, make a note, talk to me, go to the lab, get some help. Now I'm going to try and group, collect like terms on left and right. I can't do that, right? Can't put anything together on the left, can't put anything together on the right. So then I'm going to proceed to move all my x's to one side. You can do subtract 12, that's fine. Subtract 12x, subtract 12x. I have an 8 on the left side still. On the right side, 36 take away 12 is 24x and minus 15. I almost have my x term by itself, just got to get rid of that negative 15, so I add 15, right? 15 plus 8, 23, equals 24x. Divide both sides by 24. 23 over 24 equals x. And we are there. And we're going to do 2 more out of this section, then we're going to move on to the next section. There will be time at the end of class here for you to, I'm going to give you the option of staying and working or leaving. It's going to be your call. But that'll give you an opportunity to ask questions if you have any, all right? All right, here we go. Now, the next one that you should, or that I'm going to do is number 41. And at home, you should do number 40. '41 is somewhat interesting. 2/3 x minus 0.3 equals 1/15 x plus 9 over 30. Ew. All right. I don't recall us ever having this before. Fractions and decimals. Well, the first thing I look for is grouping symbols, which I don't have. Now I have decimals and fractions. So which one do you do first? It actually turns out it doesn't matter. You can do either one first. For us, though, in this problem, I think that the fractions will work out better than if we try and do decimals. Because if we try and do the decimal, right, that 0.3, I just move it over one spot. But you have to do that to all of them, right? Well, how are you going to move a decimal over on 2/3? What does it become? You know what I'm saying? It would actually become 20/3, but it's not natural to necessarily look at it that way. So I'm going to take care of the LCD and the fractions first, then we'll look at decimals, if we have them. LCD, my denominators are 3, 15, and 30. If I list out the multiples here, 3, 6, blah, 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 I go all the way down until I get to 30. 15, 30, 45, and I can keep going. 30, 60, 90, keep going. The least number that appears in all three lists is 30. You can probably just look and see that, but that's the process in case you're looking for the process. On a test, you don't have to give me this part. If you know it's 30, go with it. 30, I'm going to multiply the left by 30. 30, multiply the right by 30. I heard whoever that was yawn. I had a student last semester that he would come to class, and one time I counted, like just kind of counted how many times he yawned. It was like 50 something times. Seriously, I mean, I don't know if he had an issue or something, like, you know, but it was like constant yawning, constant. I think he actually had a respiratory problem or something. I'm not sure what it was, but it was weird. Because he wasn't tired, like he didn't act tired. He was always like answering questions and stuff, but he was just yawning all the time. Strange. So now I hear every yawn. It's like flashbacks. All right, here we go. All right, what's that multiplication of 30 to the 2/3 x? 20x, right? And then what's 30 times 0.3? So maybe you need your calculator there. Maybe not. 9. Equals 30 times 1/15 x, 2x, 30 times 9/30, plus 9 again. Right, I'm doing 30 over 1 times 9 over 30. Basically, the 30s canceled each other out, and I was left with 9. That's what happened on that last multiplication through. You have a question? No. Oh, try and multiply 30 times 9. Yeah, you could do that also. Is that, you were, no? What's up? What part? The 2x? This one right here? So 30 times the 1/15, 30 on top, 15 on the bottom. So you're just doing 30 divided by 15 is 2. So remember that 30 out front is a fraction, 30 over 1. 30 over 1. Now what? Yeah, subtract 2x on both sides. I'm getting 18x minus 9 equals 9. Add 9 to both sides. I get 18x equals 18. Divide by 18, both sides, x is 1. Okay, one more problem out of this section, and then I will move on to the next one. We okay? I'm going to do number 42, you should do 40, oh wait, I'm sorry, I'm going to do 44, not 42. You should do 42, 43, and 45. So here's 44. 2.2 parentheses 4x plus 6, close parentheses, minus 0.8x equals 4 times, in parentheses, 3.3 plus 2x. All right. Anybody still need to sign in? We have grouping symbols and we have decimals. So we said last time grouping symbols go first, right? So I need to take 2.2 and distribute 2.2 through this set of parentheses, and the 4 needs to go through the second set of parentheses on the other side. What's 2.2 times 4? 8.8? And then x, right? What's 6 times 2.2? 13.2? I don't do anything to the 0.8x. What's 4 times 3.3? 13.2? And what is 4 times 2x? 8x. If you need your calculator, you would use your calculator there. Now I'm going to collect like terms, left and right, because I don't have fractions anymore, right? Oh, wait, hold on. I'm not collecting anything. I'm decimal. I want to get rid of my decimals. Sorry about that, jumping the gun here. On the 8.8, I want to move it one spot, right? 13.2, one spot. 0.8, one spot. 13.2, one spot. On the 8, I don't want to move it, but I'm going to have to, right? It's going to have to also move one spot. So everything gets one spot to the right. So my new equation is 88x plus what? 132 minus 8x, right? It only went one spot, and it was 0.8, so to the right one is going to be just 8, equals 132. Now on this one, it's 8, so it moves to the right once, and it becomes 80. So 80x. Yes? Hold on a second. See if I copied this down right. Yeah, that's right. Okay. What now? Collect like terms, right? On the left side, it becomes what? 80x plus 132, and on the right side, 132 plus 80x again, right? Now, if we try to get our x's on one side, something weird happens here. I would maybe subtract 80x on both sides, and this is where the weird stuff happens, right? These cancel, and you get 132 equals 132. And what do you think? Does 132 equal 132? Yes. So what does that mean? All real numbers, right? Remember that? Whenever this happens and we get some statement at the end that's always true, our answer is all real numbers. And there were two ways I said I would accept that, all real numbers. You could write that, script R, or you could write just all real numbers. That U looks like a V. Okay, so what would happen, we're done with this problem, okay, but what would happen if, let's say at the end of this, instead of getting that, we would have got something like 70 equals 132. We would have said that's not true, right? And then we would have said, what is our answer? No solution. Or we would have said empty set, which is that 0 with the line through it. Or, like the book does, the empty braces like this. Set of braces with nothing in it. I'll take any of those three answers. So the reason why I told you you should look at 42, 43, and 45 is that each of those, you know, is one of these two cases. And I'll even tell you what you should get so that when you're practicing you can see. On 42, you should get the empty set. On 43, you should get all real numbers. And on 45, you should get the empty set. By the way, the answers to the questions here, right, this is actually the problems I'm giving you are out of the chapter review. So the answers are on, I'll tell you where here. They're on AN-5. 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 And you're looking in the chapter 2 review section. AN-5 stands for answers, page 5 in the back. And it has the answers to evens and odds. For chapter reviews, it gives you both. Okay. All right, we're done with that. We're going to move on to 5.1. But I'm going to pull the problems out of the chapter review from chapter 5. So this will actually be on page 392. Page 392. Now, the way this is going to work, I'm going to work through these problems, but they start off very basic, and then they slowly get harder. And the last one we do is, you know, a little tough, but not like totally blow you out of the water stuff. I used to give tests, and what my old philosophy was that I'm going to give the students like really hard problems, and if they can do those, then obviously they've mastered the techniques. Well, I've changed since then, and now it's, you know, I am going to give you easy problems on the test so you can show you understand the basic ideas. But then there will be harder ones. They'll all be equally weighted, so an easy one's worth the same as a hard. But that way you don't get penalized for not being able to do a really challenging one. Does that make sense? So if these look easy when I do them, that's kind of because they are supposed to be. So I'm doing number 1. You should do number 2. Number 1 is 2 to the negative 3. So I want you to simplify that. And all this is testing is whether or not you remember the rule for when you have something to a negative power. We don't like negative powers, right? So what are we supposed to do? Put it underneath 1. So drop it down, right? It becomes 2 to the positive third. And that's 2 times 2 times 2, which is 8. So your answer is 1/8 here. That's it. Okay, let's not make it more complicated than it has to be. The next problem that I'll do is number 3, and you should do number 4. Number 3 is negative 4 to the negative 2. So I want you to simplify that. So again, we have a negative power. We don't like that. We're going to want to drop it down. The question is whether or not that negative comes with the 4, the negative stays out front, right? That's the biggest concern we have. And this is where the use of parentheses is vital. Do we have parentheses around negative 4? No. So the negative 2 is only acting on that positive 4, we're actually looking at that negative in front as a negative 1 times a 4 squared, right? That's what's really happening, or not squared, negative 2. Right? That's what's actually happening there. Not really. I've never heard that. I'm not going to say it's wrong, but I've just never heard it said that way. I've always heard, raised to the negative 2, but I've never heard negative squared. I think anything is okay as long as you're communicating it, like whoever you're saying it to understands what you mean, right? Okay, so now that one piece, the 4 to the negative 2, that part gets dropped down. But the negative 1 stays there. So we have negative 1, and then the other piece becomes 1 over 4 squared, right? That's negative 1 times 1 over 16. And what's a negative 1 times something? It's just that something, right, but negative. So I can get rid of the negative 1 and just make it like a negative 1/16. Questions there? Okay, now I'm going to do number 5. And you should look at 6. Number 5 is y to the 6th, y to the negative 10, y to the negative 8. Now, this is the property of exponents that we had that said that if you have the same bases, which we do, and we have different exponents, we will do what with the exponents? Add them up. Now, it might turn out to be subtraction because if we're adding a negative, it's the same as subtraction. But I'm actually going to do y raised to the 6 plus negative 10 plus negative 8. I mean, that's technically what I'm doing, right? Which is the same as 6 minus 10 minus 8. So what's 6 minus 10 minus 8? Negative 12. So y to the negative 12, but I don't like that answer because it's got a negative exponent. So 1 over y to the positive 12. And I can't do anything to that because I don't know what y is, so I can't raise it to the 12th power. So far, do you feel like we're smooth sailing? Doing okay? Yes. I'm not going to test you on, like, give me the rules or match this to the rule. I just want to know that you can do the mechanical part of this. Some instructors are really big on that sort of thing, and I guess I'm not. All right, next one. I'm going to do number 7, but I'm going to modify it a little bit, okay? I'm not really going to do number 7. I'm going to do something a little different. And you should do number 8. So for number 7, modified, I want to know what 100 to the negative 8 times 100 to the 8 is. A 100 to the what? What do you do to those powers? Since they have the same base, isn't this pretty much the same as the problem we had before? You have the same base, you add the bases up. What's negative 8 plus 8? 0. Do you agree? So this is 100 to the 0, and what's any number to the 0 power? 1. The answer is 1. Just remember that. I get a lot of people that will do a problem like that, and they'll say the answer is 0. The answer is 1. Okay, number 9. Except 0. but we don't talk about that. Those are like fighting words. You know, you don't want to talk like that. 0 to 0, man. What's that? What you gonna do? All right, number 9. X to the 4th cubed. This problem steps us into a different property of exponents. This is where we called it the power to power property, or power to power rule. We have something to a power to a power. So we are going to do what to those powers? Multiply them, right? So this just turns into x to the 12th. And I'm happy with that, right? Because 12 is a positive number, so I don't have to drop anything. I'm happy. I move on. And we're just cruising. Did I go too quick? I need to go back. Number 11. You do 12. I already told you all last class that I've got some high aspirations for you. I feel like you'll have set the bar high for yourselves in my mind. I have no problem giving everyone here perfect scores, perfect hundreds on a test if everyone does it right. So I should shut up, because what if y'all don't do well? Then y'all are y'all gonna feel bad, or what? Will you feel bad? Nah. I haven't cried over a set of students' tests ever, so I've been disappointed, but I have never emotionally let it go. Okay, let's multiply, right? Power to power rule. That's a 2. Hey, what's that? 144. And just because I need to kind of throw something else in here, what would it have been if it would have been that instead? Yeah, it would have been 12 to the negative 2, and we don't like negative power, so we go 1 over 12 squared. Whoa, 12 squared, 1 over 144. So that's the difference between those two. So I just threw that in there, bonus material. Not bonus like bonus points. I'm saying bonus like extra stuff for you to see. Got to be careful with the word bonus around you guys. There will be a bonus on the test, though. At least one. All right, so here we go. You're going to look at number 14, and I'm going to do number 13. So if I've got something like this, 6 x to the 5th squared. This is that rule where we said if you have a product to a power. So the product here is the multiplication between the 6 and the x to the 5th. So inside that parentheses, you've got product. What you do is you apply that power to both products, to both factors. So it's 6 squared and then x to the 5th squared. Remember that? 6 squared is 36. X to the 5th squared is power to power, so that's x to the 10th. And am I happy with that? Yes? No negative exponents? It's all good. Ooh, 15 looks ugly. 15 and 16 is for you. Oh, check this one out. What if we have negative 4, a to the negative 8, b, c to the 5th squared? Isn't that the same as 13? except that we have, let's see, -4 there, a to the -8, a b, and then c to the, so we've got 4 different, we call them factors in there. So each one of those gets raised to the second power. Now, is this right for me to write this? -4 squared? Like for that first factor, -4, it's going to get squared, right? So is that the proper way to write it? I actually need parentheses because I'm squaring the entire thing. And we've seen there's a difference between -4 squared and parentheses -4, close parentheses squared. Then I have a to the -8 squared. Then I have b, and I'm going to square that. Then I have c to the 5th, and I'm going to square that. So each one of those gets squared. This becomes, we just said 16, because negative times negative is positive. A to what power? -16. B to the 2nd, or squared, and then c to the 10th. Are we happy with that answer? No, the only problem is that a to the -16, right? We want to drop that down. And when we say drop it down, what we mean is we're going to leave the 16, the b squared, the c to the 10th up top, and then we create a fraction out of it, and the a to the 16th goes down and stays down there by itself in the denominator. We're getting close here. We're only going to go to number 21, so we've got 3 more to look at, okay? May I move on? Okay. So number 17. Two to the 4th over 2 to the -1 equals, so this was a property, I'll write the property on the side just to remind you, x to the m over x to the n equals x to the m minus n. Remember that one? It was quotient to power, basically. You have division to a power. With powers on each one, you subtract. You subtract the bottom one from the top one. So be careful on this with the signs. 2 to the 4, what? Minus what though? See, the minus is right here, right? There's your minus. What's the n for us? -1, right? So we're actually subtracting a -1. So it's going to become a +1. So that's 2 to the 5th. That's a tricky one. That gets a lot of people. And I had a couple of students in my other class that asked me this question, and I want to make sure everyone here is clear with it. Whenever you see a minus and then you see a negative number, let's just say something like that, it becomes a plus. Whenever you subtract a negative, it becomes addition. It's like saying, I don't like you. Means what? What does that mean? If I say, it's just bad English, I understand that, but I don't like you. Does that mean I like you or I don't like you? Well, hide, first of all, act like that blue one isn't there, right? That means I don't like you, right? But then when I come in and I say I don't like you, that actually means I do like you, right? We call this a double negative. Or you could say, like, you could look at that as being like I don't squared like you, which means I frickin' hate you, right? Like don't like is a really strong don't. No, that's not what I'm saying here. I'm saying like I don't like you is what we call a double negative. By itself, one don't means I don't, right? But don'ting a don't means that I do. It's weird, but that's kind of what's happening here. You're negativing a negative, it becomes a positive. Who's in any English people here? Like enjoy English and no? Okay, if you like English, this is called double negative. It's a double negative. So that's kind of what we have in math. We have a double negative, it becomes a positive. Whatever. I don't like you. Yeah, we're moving on. Don't. Yes. Oh yeah, 2 to the 5th. I knew I wasn't done. 2 to the 5th. What's 2 to the 5th? So that's 2 times 2 times 2 times 2 times 2. It's 32. Well, that wouldn't cost you a whole lot on the test. I mean, out of 10 points, like 10 points being the most you could get, if you just leave it as 2 to the 5th, I'll only take off like 8 points. No, I'm kidding. I'm kidding. No, I'll probably just take off 1 point. 9 out of 10. So we're not having a test on Thursday, right? I'm going to regret saying that. You said we weren't having a test. What am I on? 19? I'm going to start a new page. Number 19. And you should do 20. So number 19 is negative 7 x to the negative 5 over x to the negative 2. Whoa. Stay there. There's so many different ways you could approach this. Some of you might look at that and be like, oh, x to the negative 5, we don't like that, we drop it down, right? And the x to the negative 2 on the bottom, you could bring that up, couldn't you? Is that the way you think you would approach it? Do you think so? Take your negatives down. If they're down, bring them up. Another approach would be this. Look at these and do that rule we just did, which was x to the negative 5. Take away what? Negative 2. So double negative again. That's the same as x to the negative 5 plus 2, which is x to the negative 3. I could do that also, right? Either way, the next line should be the negative 7. There's nothing I'm doing with negative 7, right? It's by itself. It's not being raised to a power, right? Because there's no parentheses around it. So that negative 5 is only on that x. So I have a negative 7 sitting there. And then after doing that blue part, I have an x to the negative 3. That's not 3. Now, am I okay with that or not? No. So drop the x down and becomes negative 7 stays on top, x to the positive 3 on the bottom. And there we're done. We're happy. Now, just so you can see it, had you decided to bring the x squared up, the x to the 5th down, right? So let's say you had done that first, brought the x to the 5th down, x squared up. Then your next step would have been you would have had to have done that, which would have become x to the 2 minus 5, which is x to the negative 3, which is the same thing that we got the other way. So either way, you should get the same result. '21, I said, was the last one, right? Number 21 is not our last one. I don't know. I don't care, right? Do we care anymore? I think we don't care anymore. 7x, ooh, I don't like that. We have in parentheses 7x to the 5th over 8x all squared. Again, you have several options here. You could look inside the parentheses first and ask yourself, is there anything that I can do to that? And is there anything I can do to the inside? Do you all see that right there? That's really an x to the 1 on the bottom, right? So I could turn that into an x to the 5 minus 1, which is x to the 4th. I could do that. Should we? I don't care. Is that okay with you? All right, so my next line will be in parentheses still 7. I had an x to the 4th. What was still on the bottom? 8. All of that's being squared. So now I'm going to try and get rid of the parentheses. How do I get rid of a parentheses on a fraction if I've got a power on the outside? The power's got to go top and bottom, right? So you've got to take the entire top, 7x to the 4th. You've got to square that. You got to take the entire bottom, which is 8, and you got to square that. How do I square 7x to the 4th? You do 7 squared, and then you do x to the 4th squared. So you square both of them. And on the bottom, 8 squared is 64. So this is like kind of like several of our properties in one. 7 squared is 49. X to the 4th to the 2nd. X to the 8th, all over 64. Okay, that's it. So here are a few problems. I told you I'm going to give you bonus. Here are a few problems that if you feel pretty good about this and you think you'd want the bonus, that maybe you should look at for bonus. 23, 25, 31, 32. Bonus type. Problems. Is there a question? You got it? All right. What do y'all think about that? Pardon me? I'm going to have bonus on the test. Like, I'm going to give you a problem. It'll be like these. Like, if you, those are good practice for what you might see on the bonus. Okay. Now, there's another type of bonus problem I want to put on the test, but where's my sign-in sheet? This bonus that I'm going to give you is really kind of just a bonus that's a reward for you being here today. So I'm going to stop the video. All right.